So it's just a shortcut. The rules for x to a power is just a shortcut. It is what would happen if we applied the limit definition. So if I ever say, and I will on the test, find the derivative using the limit definition of derivative, you must use the limit as h goes to 0. You cannot use any shortcuts for them. Does that make sense? So on the first test, I am going to make you use the limit definition, and then after that, no. Because then we'll start learning other things, other shortcuts, how they kind of interact, all this kind of business. Did I bring? Yes. So getting back into this, what's the next do there? This one was, let me catch up, negative 15 x to the negative 4. What happens here?
2/3 x to the power.
Yeah, 2/3 comes down. And then 2 minus 3 is negative 1. Kabam. And then this guy, how do you rewrite this guy? X to the 9/7. So the derivative would be 9/7 x to the 2/7. Now, one thing I don't like, just to critique myself for a moment, I don't like the way I set this up, because a really big deal later on is to let yourself know what f is, and what f prime is, and what f double prime is. What's f double prime? Just take another derivative. Couldn't you take everything we just did and take another derivative? Would that be hard? What's the second derivative of this? It would be the derivative of this, which is 20x cubed. Yes? You guys see that? So higher order derivatives, the idea of them is not difficult. But the first derivative of a lot of functions will become much more complicated, and then the second derivative is going to be more complicated. But the idea is straightforward. Just keep taking the derivative. Yes? What's going to happen to every polynomial eventually if I take enough derivatives? Zero. You with me? Because what's the derivative of x squared? 2x. What's the derivative of 2x? 2. And what's the derivative of 2? 0. So every polynomial, this is called an annihilation operator very often. It's like what level of derivative, the third, the fifth, the 18th, which level will actually eventually kill the polynomial you're looking at. There's always something that will fully kill it. You guys kind of. Yeah, so how many did x squared take? 1 went to x, 2 went to constant, 3. So it took 1 more than the power. Yeah. Now, I gotta be really careful. That only works for positive powers, or for whole number powers, I should say. What happens if I take the derivative of x to the negative 1? The power becomes negative 2, and then it becomes negative 3, and then it becomes negative 4. That's never gonna leave, is it? Okay. Yes?
Does this look back to how when you were talking about how when you were graphing that one f prime last week, how it went from like a cubic to
totally.
a squared?
And a squared would go to a straight line, and a diagonal line would go to a straight line, and a straight line would go to 0.
Okay.
Yes.
I see.
So that's why I said polynomial, because polynomials only have whole number exponents. So those will eventually die. Okay. What about number 2? Number 2 in chapter 2 would suck. Number 2 in chapter 3 is easy. Oh. How should I rewrite that function that I gave you? It's not in a good form. Yes, it should be minus 2x to the negative 1, right? Then every piece of it is in the form of the only frickin' rule we know. So go for it. Keep going. Do number 2. All right, let me try to catch up a little bit. What is the derivative? Yeah, 12x to the third plus 2x to the negative 2. Good. So if the power is negative, it just gets more negative. If the power is positive, it approaches 0 and as you do more derivatives. Okay. What does that function that we just created do? The function we just created, what is its job? Find the slope at any point. The original function's job is to tell me where the function is. The derivative's job is to tell me how it's going through that point. Is it going up through it? Is it going down through it? Is it going flat through it? Do you guys see what I'm saying? The original function's job is to tell you where the function is at a point. The derivative's job is to tell you how you go through that point. Are you going through it positive, negative, flat, steep, not steep? Yes, maybe? Screw you, Jeff? Okay. So what can I immediately do with what we just did in the direction of finding the equation of this line? Plug in. Good, plug in the x part of the point to figure out what the slope is there. So I want to figure out what f prime of 2 is. So if I throw a 2 in there, I get 12 times 8 plus 2 times 1/4. Is that cool? Which is? Yeah, what do you get, 96.5? Pretty steep. How do I get the equation of the line? Yeah, y minus the y piece equals the slope times x minus the x piece. Yeah. So I get y minus 47 equals 96.5. Oops. Minus. Is that 193? Let's see if anybody would tell me. And then if you add 40, oh, I left my x out. Minus 6.5x minus 146. What does that line do? The slope of that line is the same as the slope of the function at that point. But what does that line do? At that point, it is tangent. It only hits that function once right at that point, yes. It models the direction the function would go in if it stopped being a curve, if it went in a straight line. As we develop derivative shortcuts, number one, you have to remember them. And number two, it makes these kind of problems much quicker than they were in chapter 2. We don't have to use limit, definition, slope anymore, blah, blah, blah. The next one, whatever the hell that is, number 3. You're gonna see this a ton. I'm lagging in real life. Find where the tangent line would be horizontal. What does that mean? What's another way to say that? Where the slope is 0, yes? So find the slope, set it equal to 0. Go for it.
When you want a location, do you want a point or do you want an x value?
Next time.
Oh, okay.
Yeah, where something happens is the x. What happens there is the y. So I already know the what happens there. Now, if I said, like, find all turning points, then this would lead in that direction. There would be a little more work we'd have to do with it. Get that out. Here's the worksheet we'll be doing later. Sure. Oh, you're okay. So this guy's derivative is what? And I want to set that equal to 0, yes? I always love this idea. You get a function, you want it to tell you something. I always think about you put the function under the bright light. Shh, tell us where you were the night of. So I force it equal to 0, so when I solve for x, it tells me where it does that. Yes, bless you. If I said find all locations where the tangent line has a slope of 3, I would have taken this and set it equal to 3. Yes, because you just, I don't know, you might see a problem like that somewhere. What's a really good first step before I start to attack this? Yeah, anytime you can see that the coefficient of the x squared piece could go away, shit, yeah. So I'm going to divide by 3. Of course, 0 just eats that up. 0 divided by 3 is 0. And how do you factor this? Do it again, sorry. X minus 3, x plus 7, so then the locations, -7 and 3, kick ass. Now if I said find the points where that happens, then you would plug those in and get points. Yes? Do it again. Oh, I see. Okay, real quick. If I would have left the 3, it would have looked like this, yes? This equals 0 when x is -7. This equals 0 when x is 3. When does 3 equal 0? When does 3 equal 0? Never. That's why I'm allowed to divide by it, because it can never be 0. Yes? The only way the answer would be, one of the answers would be 0, is if I had just a pure x. Because then I can control it. And how do I make it 0? Well, I make it 0. I can only control the parts that have an x in them. I don't know if you guys are with me. I'm aware that I say things different than you're used to sometimes, but it's just the reality of what's happening. Okay. So I think you guys should definitely feel pretty good about that. Oh yeah, I forgot I did this. This is perfect. So, last, or 2 semesters ago now, I taught a course called 180L. And if you're going to take 280 in the fall, I got to remember to email you guys. There's a course called CISL, Calculus Instructional Support Lab. I think it's Math 99 or something. I'll send an email out to you guys, because you want to sign up for it if you're going to take 280. Because instead of having, okay, Math 180L, 280L was a course you signed up for. It met at a specific time, and we just did like prerequisite stuff, so that when you got to your calculus, you didn't have to worry about the prerequisite stuff. You with me? At least that's how I taught it. We now are going to have, starting in the fall, this lab. It's going to be right next to the Math Science Center. It's going to be that computer lab right next door. It's going to be faculty are going to be in there. So anytime during the day that it's open, you go in, there's going to be a faculty member there to help you with calculus questions. You guys kind of with me? So I love that idea, because the class, if you weren't free at the time, whatever, then you couldn't take the damn thing. But with this, you just come in whenever you want to, whenever we're open. Does that make sense? So just, I'll send an email, I'll tell you exactly which thing it is. All that's to say, this is one of the worksheets I did with my 180L when I taught them, because we're about to get into some of the next level stuff. These rules of derivatives of certain types of things. In order to be able to do a lot of the problems, you're going to have to be able to do this stuff. So let's look at A. There is a very common and understandable mistake people make when I tell you to simplify something like that. Now what's interesting to me is there's a non-zero number of you who want to do that mistake. And again, it's a very human thing. Because what do you do when you have a fraction? What do you look for? The most fundamental thing you look for is can anything cancel? Yes? So look at it this way. What do you think a mistake is that somebody would make? And let's figure out why it's a mistake. What looks like it just wants to cancel? One of the x squared plus 1s, yes? And you might be like, you're saying it's a problem, math boy? One's on the top, one's on the bottom. Leave me alone. What's the mistake with doing that though? If you cancel one of them and you cancel this guy is not being divided by as much as he's supposed to be. So division can't cancel part of the subtraction problem. That's not its job. What is division supposed to cancel? Multiplication. And the top is subtraction. Can't do that shit. So what do I do instead? I can't do that. You could break them up, but what you should do is multiply the top out. Here's another thing people don't understand. Simplification and factoring are the opposite things. If I said simplify 7 times 8, what do you get? 56. If I said factor 56, what's one way you can do it? 7 times 8, yes? So they are opposites of each other. So simplify, multiply shit through. So what do you get when you multiply this through? What do you get?
8x cubed.
8x cubed plus 8x minus 8x cubed. Now let's see if everybody's careful. Plus 4x, kick ass. Do you guys see that? Negative, negative, positive. And what happens there? Yep. And that's 8x plus 4x. 12x over x squared plus 1 squared. That's pretty cool. Especially if I get right. That would be amazing.
Wait, does that say x squared minus 4?
Where are we at? Sorry. Oh, down on the bottom. X squared plus 1.
Yeah. Oh, okay.
Says this,
X
yes,
squared
I'm
plus
sorry.
one.
Yeah.
Oh, okay, so you kept that. Okay.
Plus 1 and 4. I tell you what, they're just evil. You guys kind of with me? This kind of thing's going to happen all the time. For those of you who might have done any calculus, we're getting into quotient rule. Quotient rule is going to look like that. You're going to have to simplify it. There's a ton of ways you can make mistakes doing that, and that sucks. But again, just to remind you guys, the way I grade something is if you did that and it was the very beginning of a problem, I wouldn't take any more points off if everything else after that was the correct concept. I would only take points off for that first mistake you made. You're welcome. Because I had so many teachers that made a mistake on step 2. And there were 87 steps, and they're like 0 points. Anyway, sorry. What about part B? Same idea happens, right? Can I cancel sine x plus x? One of them. Because it's not in both terms, yes? You guys cool with the fact that the top has 2 terms? You guys see that? Barty's like, it's got too much shit, but it's only got 2 terms. There's big ass term minus big ass term. Okay. So what do we do? Simplify, meaning distribute. Go for it. I'll wait. I love that reaction. So a big part of mathematics is something I call math stamina. So what's funny from my perspective is just to kind of feed into the old man trope about I walked uphill both ways when I was your age, right? If you're going to major in math and go any further in math, you're going to get to a point where you're like, oh man, those problems I thought were long were nothing. That really makes me feel better right now, Jeff.
Differential equation.
Dude, differential equations. That's the best. That's when you start to have to like tape 2 together and do a problem like this.
Really?
Totally.
Oh my god.
Yeah, I did exactly that a few times.
This is my time to drop out of engineering.
Oh no. It's the coolest shit.
Okay.
That's when I had a teacher that would do a problem. He would start at the chalkboard over there and go around the room. We would all just kind of swivel watching him.
Oh hell no.
What happened in step 3? He'd run across the room. Alright, I'm going to catch up to you guys as you do this stuff. Oh boy, it's not going to be enough room, Jeff. Oh yeah, by the way, quick little side note before I forget, you don't have to write this down, but Do you guys understand there is a major difference between these two things? If you find yourself putting parentheses in, stop what you're doing and think about it. These are completely different problems. This has a completely different domain than this, for example. Yes? Derivatives of these things would be completely different. Yes? So be really, really careful. Okay. Also, real quick, before I forget, we're going to see a lot of stuff like this. And I always have somebody that at some point does this. Maybe I've already had people do that. So one of my students in the past said, this symbol should have a back wall. And I'm like, you're exactly right. That symbol should have a back freaking wall. Yes? And that's why things sort of bleed in there. And the minute you do that, you're screwed. So be happy you have a teacher that actually gives partial credit. Now, is everybody cool with that? That's just brute force distribute, right? And you guys be careful. Was I careful? I was careful. Look at me, be careful. So no, it doesn't matter. You can't go wrong. Anything happen right off the bat? Oh, did I make a mistake?
No, I just have a question. So
Yes.
that third term, 4x sine squared of x, if you put the sine x in parentheses and put the 2 on the outside,
That's
is
what
the
this
same-
means.
that's the
That
same
means
thing?
this.
Okay, cool.
It's just math people saying, we're lazy or efficient with our time, depending on how you feel about us.
Okay.
So we just put the square there. Is everybody cool with that? Now, the one thing you cannot do is this is not the same as that, for damn sure.
Oh yeah, because that's sine squared.
Yeah.
That's sine.
So this means this, whereas this means that, yes? On the first one, the sine x is being squared, and the second one, the x is being squared inside of the sine. You guys see that? Okay. Which again, I understand is part of the reason why people get turned off to mathematics. But at the same time, some of this shit is really weird to try to figure out how to display it. Okay. Does anyone, so besides this, die. Anybody else see anything else that happens? There's one more thing that happens on the top there. That's really easy to miss.
Don't we have a 4x sine squared minus 4x cosine squared? Which
Yes.
is, we can say, like, because there's the rule that sine squared minus cosine squared equals 1.
So if I take a negative 4x out of these two terms, what is left on the inside?
A sine x squared minus cosine x.
No.
Oh, plus cosine.
Plus.
Which is 1.
And of course I have this term at the end, yes?
That's 11 years.
Even 11 years ago, this was 1, yes? Sine squared plus cosine squared is 1. And if you remember sine likes y, cosine likes x, it only makes sense since it's in a unit circle, x squared plus y squared is 1, because 1 is hypotenuse. One more example of SOHCAHTOA sucking. Okay. Sorry. And then, there's too much more to do here. Is everybody semi-cool with that? If you see a squared trig function, you should just slow down and look for a possible identity. Do you guys know your squared trig function identities, otherwise known as the Pythagorean identities? Because we can't stop giving this cult leader props. He was a cult leader, Pythagoras. Anything else? I'm sorry. Sine squared x plus cosine squared x is 1. What's another one?
Tan squared theta plus 1.
That's true. Huh?
Tan squared theta plus 1.
Oh, okay, sure, we can read it all.
Yep.
If you start with sine squared plus cosine squared equals 1 and divide by cosine squared, you'll get sine squared over cosine squared is tangent squared plus cosine squared divided by cosine squared is 1, tangent squared plus 1. I love you guys. So if you start with sine squared plus cosine squared and divide by cosine squared, yes? What's sine over cosine?
Tan.
Tangent squared. What's cosine divided by cosine? 1. And what's 1 over cosine?
Cosecant.
And guess what the other one is? Co-shit. Jeff, not that much. Co-shit equals co-shit. Isn't that crazy? Now, of course, that was another earlier example about why we call the co-stuff co-stuff. Because co-stuff seems to go together. calculus is going to show you even more ways that they go together. Are you guys all right? I mean, I'm sorry. No? What's up? Are we okay with this problem? Not with any of the tangential stuff I just spoke about. How are we doing with this problem? Yes?
I'm confused. Why did you cross the sine squared x plus cos?
Because what is sine squared x plus cosine squared x? It's equal to 1.
Oh.
That is a truth. That is an identity.
Okay, so that's okay.
So all I have left here is 4 cosine x sine x minus 4x minus 4x squared sine x. And if I don't see anything meaningful that would happen after that. There's another identity you could do, but it doesn't do anything for you. Okay. So this type of thing is going to happen to us in the very, very near future, meaning today. Let me do this. Okay, we're going to come back to this here in a minute. Just everybody, just we'll come to that in a minute. I don't want to get too far ahead of myself here. What I'm just remembering is I forgot to try something out ahead of time. So we're going to do this live. We're going to do it together. I want to prove. Okay, let's do it this way. I want to figure out what f of x times g of x, what the derivative of that's going to be. If I have the product of two functions, what should its derivative be? Then, in order to prove derivatives, we're going to use the limit definition of derivative. But the minute we've done that once, I've developed a fundamental process that I can just use directly. So we're going to develop, you're not going to believe what we call this rule. That is the product of two functions, so we call it the product rule, which, makes sense, but I like to make fun of us. I'm going to do the limit definition of derivative to this thing. And it's not going to be pretty, and there's going to be one step that will be freaky as hell. Okay. Do you ever have to do this by yourself, what we're about to do? Not at this level. If you go far enough in math, you're going to be doing a lot of what we're about to do. So this is a function, correct?
Yes.
If I had f was x squared and g was 3x to the 7th, what's f times g? Which is 3x to the 9th. So whatever f is, whatever g is, when I multiply them, it makes its own function. It's its own function, correct? So if I want to figure out the derivative of this, I would do the limit. Let me give myself a little more room. How does that work, though? How does the limit definition work? It's the limit as h goes to 0 of the function evaluated at x plus h, correct? My function is f of x times g of x. What does that look like evaluated at x plus h? That's right, kids. F of x plus h times g of x plus h. Minus evaluated at x, all divided by h. Is that okay? That looks trippy, because I'm assuming I have a function that is the actual product of two separate functions. Yes? Okay. Do you all agree with me that it seems like there's not a damn thing I can do? Do you all agree? Can you factor the top? Hell no! No. Now so what I'm about to do, I desperately need you to hear me. There's no reason in the universe you would ever think to do what I'm about to show you. Back in the day, before they had, like Xbox, which I have one. I'm playing my Oblivion Remastered, you better believe that shit. Before they had even Ataris or shit. Back in the 1600s, they had candles, they had, not much going on. So they had a lot of time to sit around and play with shit. They came up with what I'm about to show you. Once you see it, if you go far enough in math, you actually start doing it every now and again. It just becomes this really smart thing to do. What I'm going to do is out of nowhere, and this is the part I might have to do it twice. I'll see if I can think about it as I do this. I'm going to add and subtract the same thing. When am I allowed to do that? If I had the number 7, and if I add 8 to it and subtract 8 from it, did I change it? So when am I allowed to add something and immediately subtract that same thing? When am I allowed to do that?
Always.
Any damn time I want to. When is it useful? Much fewer times. Yes? Much fewer times. I don't know if you guys remember completing the square, but you do something very similar. You add something, subtract it, so that you're able to do other things. Okay. So what I'm about to add, I was hoping my subconscious would be working on this. Jeff, what is that? I'm gonna add, I'm gonna subtract. Here, let's see, let me think. Think ahead, Jeff. You can do it, buddy. Yeah, I'm gonna subtract f of x, g of x plus h. And I'm gonna add f of x, g of x plus h. And you're all gonna say, what the shit is wrong with you? You weird dude. Yes, ma'am.
I'm just confused.
I understand. What did I say? There's no way in hell you would have ever thought to do this. Now, number one, you guys see how what I just did is not incorrect? Meaning, what do these do to each other? They cancel. So did I actually change anything? Go ahead.
Shouldn't the second one be g of x? Like f of x and then g of x?
Oh, here?
Yeah.
No. I don't want it to be that. Okay, real quick. That is there, yes? I need you to see this. That is there.
Okay.
That is there. In the middle, I just put two things that make
Oh.
0.
Oh,
Okay.
So, did I just do anything?
No.
Good job, Jeff. Wasting ink. You person. Okay. I almost said you fine. So, here's why I did that. Do you guys see, if I kind of break these up, and again, dear God, no way in hell I would expect anybody to think about doing that. Not because we're not smart enough, because that's weird. What the shit? But what does this do for me? If I break this up into the first piece, plus the second piece. So I got these two here. Do you start to see something in there? Like, what's common to this? What can I take out of the top in that first dude? G of x plus h. You guys see that? So I'm going to take a g of x plus h out. And what am I left with on the top? You can do it. Take a g of x plus h out. What am I left with on the top? You can do it. Take a g x plus h out. What am I left with? F of x plus h over. Does that look familiar at all?
Yes.
Yes. And here, what can I take out? What can I take out here? F of x is the same. And what am I left with?
G of x.
What is the limit? All right, here, let h go to 0 here. This is kind of dumb. What do you get if I let h go to 0 there? Oh, God, I did it again. Sorry, guys. Hold on. Part of my brain was like, what's happening to me? Okay. It happened to everybody. You guys cool with that? If I let h go to 0, I get g of x. That's crazy, isn't it? And what is the limit as h goes to 0 of this shit? Do we have a symbol for that? The limit as h goes to 0 of this shit? Do we have a symbol?
F prime.
That's freaking f prime, yes? You guys see that? Plus, as h goes to 0, what is f of x? Freaking f of x. And what is the symbol for this? What is the symbol? G prime. So let's analyze what this is telling me. Next page. So where you got all that? Do you ever have to redo this? Maybe for a bonus at the very most, right? I would make this a bonus problem. You with me? I'm never going to make you do this yourself. I'm just really happy I remembered what weird shit I had to do here.
Wait, so is this like another way to do derivatives the manual way? Or
No, this is the way to do derivatives.
Oh, okay.
But what functions was I just now working with? What functions were we working with?
Okay.
Every function.
Okay.
We just worked with every function in the universe. Do you understand?
Mhm.
You take any two functions in the universe, you multiply them. And how do you take its derivative? Like this. So what does this rule say? It says if I have a function that's actually the product of two functions, how do I take its derivative? I take the first guy's derivative, leave the other guy alone, plus the first guy times the derivative of the other guy. They take turns. This is huge. Every frickin' derivative rule involves the idea of all the parts gets to take a turn. They each get a turn. So just to have a very simple, silly example. We've looked at functions that are results of products. We have. One of the most basic ones is x squared. Isn't x squared, isn't that x times x?
Mhm.
So if I do the derivative of x times x, I better frickin' get what? What's this guy's derivative? 2x. So if I take the derivative of x times x, how do I do that? It would be the derivative of the first one times the second one plus the first one times the derivative of the second one, yes? Is everybody with me? You take the derivative of the first guy, leave the second guy alone, then the second guy gets a turn, leave the first guy alone. That is the product rule. That's what it states. What is the derivative of x? 1. It's the same thing as saying what's the slope of x? 1, yes? So this is x plus x equals 2x, right? 1 times x plus x times 1. If I were smarter, I would have started with this and said, what if I just do the derivative of each one? That's 1 times 1. Is that the correct derivative? Shit, no. The derivative of x squared is not equal to 1. So that can't be the rule. I can't take each of the derivatives at the same time. They each get a turn. Some of you guys look so excited. I don't blame you. The unfortunate thing about product rule is it doesn't get its full power until later, but this is why I did one thing for myself. Can somebody remind me what the derivative of sine is?
Cosine.
Now, so what if my function was this? I could distribute, then it makes it worse. I don't know if you guys see that. Do I have the product of two functions? Do you want to use limit definition of derivative to evaluate it? Oh, hell no. In fact, I never want to, Jeff. Okay, I understand. Limit definition derivative, at this point in this class, its utility is improving general processes, which involve how many functions? Every. So I don't look at specific functions anymore with limit definition. I prove general processes. So now we know how to handle the product of any frickin' functions in the universe. I do the first one, so they each get a turn. Yes? So how do I handle this? What's this guy's derivative? And I tell people, when you're about to do the derivative of something more complicated than just a single function, you want to write the rule for yourself. So what's the rule say? Do the first one, leave the second one alone, plus what? Leave the first one alone, let the second one have a turn, yes? Now some of you guys are not going to do that because it's going to be relatively easy functions, but you have to trust me. When we start getting more and more complicated processes, if you just write the process first, now I can focus all my attention on the parts that need something done. That first guy needs his derivative done, the last guy needs his derivative done, everybody else is cool, right? So what's the derivative of 4x squared plus 8x? Do it again, 8x plus 8 plus, what's the derivative of sine x? There you go. And you can distribute and bullshit, but it doesn't really get you anywhere, do you guys agree? Nothing goes together, so screw it, I'm not gonna do that shit. If I plug a number into this, it tells me the one. slope of the original function at that point. Right? Anytime you take a derivative, that's what it means. Okay. How are we feeling about this? Product rule, hungry? Alright, should have ate something early. Product rule is not difficult. The derivation was weird. I agree. But the application of it is hopefully simple. This idea, though, carries through. If I have multiple pieces to my function, they don't get all the same term at the same time. The same turn at the same time. You can't take everybody's derivative at once. It just does not work that way. What do you think we're going to do next? So you guys can get an idea of a teacher. Yeah, say it. Quotient rule. If we talk about what if I have the multiplication of two functions, now we're going to talk about what if I have the division of two functions. Yes? Okay. Yeah. So just to cut to the chase. Given this. In fact, let me call this Q. Q prime is going to be the derivative of the top times the bottom minus the top times the derivative of the bottom, all divided by the bottom squared. Now that is trippy. That is exceptionally trippy. If anybody really wants me to, I will show the derivation for that. But it essentially boils down to a very similar step to the one we just did with product rule. Why is this so much worse? Because the first thing was freaking fractional. Yes? In fact, let me ask you this. If I brought the g up, what would have to be the power on the g? You could do this. If I had 7 over x, how do you rewrite that? 7x to the... Okay, now really think about what you just said. Which function up there effectively has a negative exponent? G does. What happens to my derivative when I take the derivative of g? When I get g prime, it becomes negative, yes? Do you see how the top looks like product rule? Except for the minus? So if you switch these two, you're wrong, yes? So has anyone ever heard the song, high, low, low, high, blah, 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 blah? It doesn't go like that. All right, here's my take on that. You obviously know that I think that's bullshit. I hated it as a student. I always got it turned around. If you understand why that piece is negative, why is this piece negative? Because I'm taking the derivative of the one that's on the bottom. What's the derivative of something to the negative 1 power? Doesn't the negative come down? So of course that's the one that's minus, yes? So you ready for my song? My song is top first. That's it. That's my song. Sung the way I sing. Top first. Okay, sorry. I love you guys. Why is it over g squared? Because it is. Look at it. Maybe I'll put something online. Okay. For the derivation of this, if you want me to. I don't think it would help us at all if I show you the derivation of this. I don't think so. Let's try an example. In fact, let's do this. Let's start off with this. What's the derivative of x squared again? All right, so anything I write that is equal to x squared better have 2x as a derivative. Does that make sense? Anything I write that is equivalent to x squared better have 2x as the derivative. We used that fact earlier when I rewrote it as x times x. What if I rewrite x squared as x cubed divided by x? The derivative of this better be what? 2x. Freaking 2x, because it is x squared, correct? All right, now listen, what I'm not saying right now is I'm ever going to ask you to use a quotient rule on this. Would you? You would divide the damn thing and then do this derivative, correct? What I'm trying to do is apply a new rule to a form we know already what it's supposed to be, because we better get that answer. I know what the answer is. This better be frickin' 2x. Or the whole thing is shit, Jeff, and we can go home. And now everybody's like, make a mistake, Jeff. All right. So how does quotient rule work? It says top first Derivative of the top times the bottom minus the top times the derivative of the bottom, all divided by the square of the bottom. Yes? Now listen, if you know the song, or if you want to ask a tutor about the song, feel free. But I always feel like songs take us away from ideas. And ideas are the most important thing. They are what we build on. I don't build on songs, I build on ideas. So if I'm having a song replace the concept, not good.
What if the y equals negative b sum?
What is it?
Y equals negative b plus or minus the square root.
Oh God.
That's square one.
What is it?
In X
All
equals
over.
negative
That's
b.
right. All over 2 or something stupid. Yeah. Oh my God, help us. Okay. No. I used to joke that when I go senile, we walk around going negative b plus or minus. Give me like a month, and I'll be like, all right. So how does this? Everybody cool with this? I mean, we just talked about it. If you've never taken any calculus before, this is so freaking new to you. I could show you the derivation, like I said, if you wanted to. How do I take the derivative of a quotient? Top, leave the bottom alone, minus top, the bottom gets a term, divided by the bottom squared. Do you have to memorize that? Hell yeah. Why? Because I am an asshole. What's the derivative of x cubed?
3x.
Good, 3x squared times x. What's the derivative of x? 1. So I get 3x cubed minus x cubed divided by x squared. What's 3x cubed minus x cubed? What's 3x cubed minus x cubed? No, dear God. Sorry. I have 3x cubes, and you take one of them away from me. There we go. Okay. We can only, you lose something that's changed by multiplication using division. Okay. And what's 2x cubed divided by x squared? How many x's do I lose? So I have 1x left, yes? Is that what it was supposed to be? Of course. Am I saying, should you ever do all this for this problem? Of course not. I just want to show you an example of, I know what the derivative is. It better come out the same if I use this different rule. Because the whole idea of the rule is, it works. If I write something in the form of a function divided by another function, the quotient rule works. But dear God, if I give you this problem, if I said f of x is x squared minus 1 over x plus 1, dear God, do not use quotient rule. Unless I say to like a jerk. Why would I not use quotient rule on this? What would you do first?
Factor.
So here's a major thing. I'm going to say this many times, and if you happen to take me for 280 sometime in the future, I'm going to say it again. Before you do calculus to a function, you simplify the function. Sometimes you got less calculus to worry about then. How can I simplify this? Yeah, x minus 1, x minus 1 over x plus 1, die, so I get x minus 1. What's this guy's derivative? Freaking 1. Would you get the same answer if you did quotient rule? Of course you would, but it would take you a long ass time, yes? So anytime, listen to me, you know I'm going to do this. You know I'm going to do something like that. You know I'm going to do something different that's like this. Anytime I say, hey, do some calculus to this thing, step back and go, can I simplify that at all? Yes? Okay, maybe. Especially if you're about to do quotient rule. Quotient rule kind of sucks. Okay. In fact, when I was a student in 180, I actually didn't do quotient rule. We have to learn a few more things, and then I'll show you what I did. And then I'll tell you not to do what I did. It was a really dumb thing, but I'll be alright. Okay. So, we got product rule, we got quotient rule, yes? So here, you guys try this one. Alright, take the derivative of that. Yeah.
Can you just explain how you got one again with this? Like I know, so x.
Oh no, so yeah. What's the derivative? It also is known as the slope. What's the slope of this?
Oh, 1
What?
because the
Yeah.
x. Okay.
So you'll start to realize as you do more calculus that if I say what's the derivative of 3x, it's 3. The x basically goes away. And why does it do that? Because it's slope and it's a line. Yeah.
Thank you.
You're welcome. By the way, just to help you, if you're trying to simplify this, you can't. I appreciate it if you are trying to, but just attack it with the quotient rule. If it made the bottom x minus 1, you would have been able to do something, believe it or not, but you can't. So you can quickly see this is why I desperately try to get you guys to write the idea. So the idea is the top goes first and the bottom stays the same, minus the top stays the same, the bottom gets its turn, all over the bottom squared. Because that's a lot. There's a lot there. So instead of worrying about all the parts and doing all the derivatives all at the same time, holy shit, let me worry about the form of it. Now I can focus on the derivatives. I've separated the things I have to do out. So I always like to tell people this. I already said this. Does anyone draw?
Oh yeah.
Have I already gone through this? I don't know what the hell I say. So I just naturally break things into parts. Those of you who don't do that, you have to kind of force yourself to. And then math becomes a lot easier. So what's the derivative of x to the 1/2 minus, oh, sorry.
Why is there an x plus 1 squared on the bottom?
Oh, okay. That would come out if I did the derivation of the quotient rule like I did with the product rule. If I did, okay, real quick, side note. If I did this, so given this, and I do f of x plus h over g of x plus h minus, in fact, I can do one step for you that'll show you what's up. You with me?
Mm-hmm.
Don't I want to kind of like get these together? Wouldn't that involve multiplying this one by g of x plus h, g of x plus h, this one by g of x, and make like denominators, yes? If I let h go to 0, isn't this g squared?
Yeah.
Done, okay. That's why there's a g squared on the bottom, because that's what would happen if I did it. I can at least show that much. I agree, you're right. That will, getting LCD leads to g squared on the bottom. Okay. Because that is probably the weirdest part about this whole thing, is why the hell is the bottom square? What is the derivative of x to 1/2 minus 1? 1/2 x to the negative 1/2, good, times x plus 1, minus, leave this guy alone. What's the beautiful derivative of x plus 1? 1. Kick ass all over x plus 1 squared. And this, dear God, trust me, trust me, trust me, so many of you are going to cancel one of those x plus 1s. Again, I am going to blame you, meaning I'm going to take points off, but at the same time I don't blame you because it's a very human thing. We're like, something can go away out of all this mess. Why wouldn't I let it go away? Don't, because it's wrong. What do I do next? This is me prepping you earlier. What do I do next?
Simplify.
Distribute, yeah. Yes? So what the hell is 1/2 x to the negative 1/2 times x? Kick ass, just add powers, yes? 1 minus 1/2 is 1/2. And then I get plus one of these guys. What happens over here? Kick ass, and that's a times 1, right? So you didn't really need to write that. And then what can I put together on top?
The x to the 1/2.
Yeah, I got 1/2 x to the 1/2 minus x to the 1/2 is minus 1/2 x to the 1/2. And then, you know, you could put the 2 on the bottom and shit, I don't care. There's really nothing, at the moment there's nothing good to do. at the moment. Later, it depends on what I do next. All right, let me see if you guys are cool with this. If I was about to figure out where this has horizontal tangent lines, I want to set this equal to 0, which means I'd have more to do. I'd have to factor the top so I can see when it equals 0, correct? So what you need to do is dependent on what you need to do next. And in this problem, what do I need to do next? Nothing. So I can just circle this shit. Not sure if you guys are really with me. Yes?
Can you go over how you simplified the last part?
Oh, are you cool from here to here? From here to here?
Yeah.
Yeah, because I distributed, and then I distributed a negative, and then 1/2 of these minus a whole one of these is negative 1/2 of these. Do you see how that is here? And 1/2 of these minus a whole one of these is negative 1/2 of these. Okay.
I think you missed the +1.
Yeah.
Oh, the +1? Yeah, I left the +1 out. Sorry. +1? Okay. All right. So, last idea for today. And then we have a little handout that goes over this idea, and then it's got some practice problems on the back. All right, this one is probably the trippiest one, and it is one of the most useful. So let me show you an example. If I want to take the derivative of this, do you guys see how I could use product rule, yes? Or I could even FOIL this thing out, correct? And then I have a polynomial easy. You with me? So I could either write 2x plus 1 times 2x plus 1, and then I could use product rule. Or probably what most of us would do is just FOIL the damn thing out. You with me? Do you want to do either of those things? Why do that? No. No. No, Jeff. No. This would be like what I said earlier. You have to put a row of paper and tape them together as you do the problem. No, I don't want that shit. I don't want you to give me a scroll. Here's my homework, a scroll. Scroll it out, Jeff. Okay. Go outside into a parking lot and open it. No. There's gotta be a shortcut to this dumb thing. That looks like it wants to be easy. Yes? So let me show you the idea. I really want you guys with me. You either write 2x plus 1 200 times and then apply product. Or you then multiply it out and then you have a polynomial and then you take its derivative. I don't want to do either of those things. No. So, let me go to an easier example. We'll come back to him in a minute. What if I had, I'm going to go to a very, very easy example. What if I had 3x squared cubed? Oh, this is where I should, this is true. I should go back to the sheet here in a minute. Do you guys see how there's a function inside of another function in both of these problems we're looking at? What's the inside function for g? 3x squared is inside. And what's the outside function? Cubed. You with me?
So can you write like a composition function for this one?
We don't have to write it like that. We have to realize it is that. So the process we're about to look at is a situation where I have a function inside of another function. It isn't two functions multiplied. It isn't two functions divided. It's frickin' somebody took a whole function and shoved it into another function like a turducken of math, yes? You guys know what a turducken is? Turkey stuffed into a duck stuffed into a chicken, and very often that's plopped into a thing of oil and things go bad and they post a video. So anyway, this is me shoving one function into another one and going, what's going to happen? We know what the answer to this is. So the smart way to do this specific one, which I can't do with this, is what the shit is this? Can't you cube this? What do you get? 27 next to the 6. And what is the derivative? Don't tell me the number. Tell me what you would do.
27 times 6.
6 times 27,
X to the
which is 162, x to the fifth. Good, right? We know the answer already. And you're like, you're doing the same thing you did? Yes, I am. So we already know the answer is supposed to be. Any process I use that doesn't end there is not the right process. So let me do wrong. Let me do something wrong. You ready? I'm going to do something wrong. I'm going to say, whatever, Jeff, what the hell are you talking about, dumbass math boy? I just have something to the third power. Wouldn't the 3 come down? And then that goes down, Jeff, goes down to 2, goes down by 1 to 2. You guys with me? That is wrong, by the way. That is wrong. Don't even write that shit down. That is wrong. To you, it should feel wrong. There's a whole part of the problem that makes the answer grow that hasn't been taken into account at all. If I put a 4 instead of a 3, won't the rate of growth be different? And this seems to have totally ignored how quickly. So if I'm on a train and you're there and I go by, you see me going at a certain speed, correct? All right. This is non-relativistic, by the way. We're not approaching the speed line. If you watch and you see me, I look like I'm going a certain speed. I think I'm just standing there, and you look like you're going somewhere. If I throw a ball forward, is the ball going faster than me or the same speed as me?
While you're on the train?
Yes?
Faster.
Good. So the rate of change of something inside something else that itself is moving is going to overall be quicker or be different. You guys kind of with me? Maybe, has anyone ever watched Mythbusters? You ever heard of the show Mythbusters?
Yes.
Okay, some of you guys. Maybe I brought this up before. There's one beautiful one where they have a car going at a certain speed and then they shoot a ball out of a cannon kind of thing. And if you do it at the exact right speed, the ball just drops. Because it's going the speed of the car, so when you shoot it, it's actually not moving at all relative to the ground. It just drops, right? Which is so trippy. But that's the way shit works, yes? So, I look at 3x squared like it's on the cube train. So what I've just done is wrong. How do we know it's wrong? Because what does it simplify to? 27x to the 4th, is that right? What am I missing? Let me see if you guys can see this. What am I missing? Do I have the right number of x's in my wrong answer? How many x's am I missing? 1. Do I have the right coefficient? What number am I missing?
6.
So I'm missing 6x total, right? What's the derivative of the inside? What's the derivative of the inside?
6.
Exactly what I'm missing. So I have to take into account not just how fast the train's moving, but also how fast the stuff inside the train is moving. Does that make physical sense by itself? So what is the right thing to do here, Jeff? This is wrong. If you wrote this on your paper, make sure future you, hey, you, this is wrong. If you didn't write it down, you're golden. You also follow the order, which is good. So the right way to do this, if I don't for some reason want to just simplify it, is I take the derivative of the outside function times the derivative of the inside function. I really want you to see this. Something cubed, how do I take its derivative? The 3 comes down, the something is now squared. That's how I take the derivative of something cubed, correct? So I do the derivative of the outside function, then I make a chain. I chain onto it, I link to it the derivative of the inside. It gets a turn. This is still going along with the idea of every piece gets a turn. The outside gets a turn, the inside gets its own turn. Now is this going to be correct? I get 3 times 9x to the 4th times 6x, yes? Which does come out to be 162x to the 5th. Which is what it's supposed to be, yes. So very quickly, before I give you this next thing, I think you guys might be able to tell one huge piece of this is being able to tell what the shit the inside is and what the outside is. So these, I gave so much room for these, and you don't need a lot of room. What's the inside function for part A here? 3x squared minus 5x. And what is it inside of? 5th power. What's the inside of this? Square root of x minus 3 plus 7x. And what is it inside? Natural log. What's the inside here? I like this problem.
Sin
Sine x, and what is it inside of? E to something, yes? So the outside thing is e to something, the inside thing is sine. We don't know the derivative of e yet. We don't know the derivative of ln yet. That's okay, because I just want to know what the inside and outside are.
So when you're writing the outside function as to the fifth power, you just write it in English fifth power.
For like this problem? Now this problem we can do. Let's do this problem real quick. How do I take this guy's derivative? What's the outside function? So I say to myself, I have something to the fifth power. How do I take the derivative of something to the fifth power? The 5 comes down in front of the stuff. 5 stuff. The stuff is now to what power?
4.
4. And then the inside gets a turn. Yes? How do I know when I'm done when there's no more inside shit? When I take this guy's derivative, I'm done, correct? Do you guys understand there could be something inside of something, inside of something, inside of something? Russian nesting dolls, have you ever seen those? It's a really good show, by the way. Russian, is it called Russian Doll? Anyway, sorry. It's on Netflix, it's really good. I know I'm done because 3x squared minus 5x doesn't have anything inside. It's just got x inside, so I'm done when I'm done with this. In fact, real quick, before I forget, and by the way, just to finish this up, what would this be? 5 times 3x squared minus 5x to the 4th times what? What's the derivative of this? 6x minus 5. Okay. And then you should bring this out front and put the 5 times above. Who cares? You have been doing this thing, and the name of this thing is chain rule. The chain rule is when I have a function inside of another function. We've been doing this entire time. So if I have this function, x squared, what's inside? X. So what's the derivative of something squared? The 2 comes down, it is now to the first power. Times the derivative of the inside, but what's the derivative of x? 1. So the reason I didn't talk about chain rule, even though we've been doing it, is because it doesn't show up unless the inside is more than just x. If the inside is just x, its derivative is 1, who gives a shit? But I really want you to realize, we've been doing chain rule this entire time. You just didn't know. Because the derivative of x is just 1. It's only when the inside is more complicated than just x. So, here, to do something we actually can do. What's the derivative of sine of x squared minus 5x? What's the outside function? Sine. So what's the derivative of sine of something? Cosine of stuff. Times the derivative of stuff. Yes? So then I would get, I'm going to put this out front. 2x minus 5 times cosine of x squared minus 5x. So when does chain rule come into play? Whenever I have a function more than just x inside of another function. Derivative of sine of something is cosine of something. But then that something gets a term. That's what chain rule says. Ian. Darn it. You'll get it later. So here's this. People always choose the worst times of the week. Hilarious.
I know I can do this. Yeah, you went read it. I think it's like over this class, and then this. Yeah, and then this. And I told you about that. Yeah. And then no, that's it. Did you do the thing that particle is actually more long?
No.
Yeah. Okay.
You're just going over this.
Yeah. Yeah, he just went over those.
We're insane. It's almost like we're in a summer calculus class. Okay. So I've got on this page I got an idea of the kinds of derivatives we can do without the chain rule. No, we can't do this one yet because we don't know the derivative of tangent yet, but we will. And this is the types of derivatives that we can do only with chain rule. So do you guys really see the difference between, now to be really honest, I don't have to use chain rule on this, but I would much rather use chain rule than freaking raise that to a 5th power. Yes? Okay, maybe. This is what it looks like, fully borne out here. Derivative of the outside times the derivative of the inside. This is even worse. But this is going to show up later, so I really want this to make sense. If I have y as a function of something else, and we call this u, it's going to be the derivative of y with respect to that times the derivative of the inside function. So that basically says the same thing, just with worse symbols. Okay. So I have a couple of examples. I was given this. The 3 comes down, the inside gets its own term, kabam. Same thing here. Rewrite that as a 1/2 power. Very similar things happen. Maybe try to do, why did it give us tangent? Why? Well, why did it give us E? We don't know this. Oh wait, did I skip that? We might know what those are. I always forget when those come into play. Oh, yeah, they're right there, Jeff. All right, let's do that. Here, I got so excited about chain rule. Let's put chain rule on hold for a moment. This is beautiful because we can come back to it first thing tomorrow before we do review. Here, you guys remind me the derivative of sine. We've already done this a few times, right? So this is cosine. Now, I could do something very similar to what we just did earlier to get sine. The derivative of cosine, I sort of gave this away a little bit, but just to kind of show you guys a little bit. Do you guys see how the slope is 0 right here? The slope is negative here, and the slope is 0 again. So see how that's the negative of sine? Because it goes down instead of up? Maybe. And I could, I'm trying to stay away from it, but I could do all of that, just like we did earlier for sine. And sure enough, at the end, it would come out as negative sine. Now, with that information, I can now, meaning you, can figure out if I'm given tangent, what's its derivative? I don't mean using limit definition. How do you rewrite tangent in terms of other trig functions? Sine x over cosine x. And then what rule are you going to use then if you rewrite it like that?
Quotient rule.
Quotient rule. Okay, guys, do it. What do you want from me? Somebody looked at me like, dare you? Dare you? I loved it. That just made my whole week, whatever else happens. Can't believe this guy asking me to do shit. So just in case you're not sure what's happening, if you rewrite tangent, because I don't know what the shit this is, and I don't want to use limit definition on tangent, do you? If you do, you can do it that way instead.
Hell no.
Okay, so if I rewrite this as sine x over cosine x, I know both of those derivatives, and I know the quotient rule. So I can develop, this is what I meant earlier by, we're not going to use limit definition of derivative as often anymore, just to kind of prove some general rules, because once we know general rules, I can build other functions' derivatives. Tangent is composed of other things that I already know. So how do I take this guy's derivative?
The derivative of sine x
Good. Top first. Top first.
minus
Minus Good. The bottom gets a turn. Divided by?
Cosine x squared.
Good. Square that. What's the derivative of sine? Cosine. So I get cosine squared. Is that cool? What's the derivative of cosine? Negative sine. And what's negative sine times negative sine?
Sine x squared.
So I get cosine squared x plus sine squared x. What is cosine squared x plus sine squared x? 1. And what's 1 over cosine squared?
Secant squared.
Secant squared. So what's the derivative of tangent?
Secant squared.
Secant squared. Oh, yeah, hi. Now, real quick, let's see who was paying attention earlier and who understands that analogous situations happen all the times in math. If the derivative of tangent is secant squared x, what's the derivative of cotangent x? Good, somebody who's listening. All the quotients negative. Derivative of cotangent x will be negative cosecant. Yes, negative cosecant squared. Derivative of tangent is secant squared. Derivative of cotangent is negative cosecant squared. Negative. There you go. Oh, it's basically time, but checks notes. I am an asshole. That's right. Last thing for today, guys. Last thing. Very last thing. Damn you, Jeff. If I want to get the derivative of secant, this is going to be the weirdest one. Well, cosecant would be a little bit weirder because it's negative. How can I rewrite secant? 1 over.
1 over cosine.
Good. So now we've rewritten secant in terms of something whose derivative we know. If I really wanted to, I can write this as cosine x to the negative 1 power. Yes? Is that cool? No? Maybe? I could do quotient rule on this, or I could just do chain rule on this. I'm weird, so I like chain rule better. So if I take this guy's derivative, the negative comes down. Comes cosine x to the negative 2 times derivative of the inside, yes? What's the derivative of cosine? Do it again. Negative sign, take gas. So negative, negative becomes positive. I'm not sure why I keep writing it like that. It's okay, Jeff. And if I write this as sine x over cosine x times 1 over cosine x, I'm aware I'm doing this a little fast. What's sine x over cosine x? Tangent x. And what's 1 over cosine x? Secant x. So the weird shit about secant prime is it's secant x tangent x. I'm going to write like that because that's the way I have it thought. Derivative of secant x is secant x tangent x.
Secant squared.
Nope.
The secant.
What?
The left is secant.
What do you mean?
Squared.
No, because I split cosine up. One cosine went here and one cosine went there.
The left, the one on the left took prime that one.
This one?
Yeah, that one.
No, why? No, I started with the derivative of secant. All right, guys. Thank you for everything. We're putting up with everything, and I'll see you all tomorrow. I'll have the quizzes graded. I'll have the answer for the practice test somehow.
Is tomorrow just a review day? for
No,
the
we're gonna
lecture?
finish up 3-4,
Okay.
and then the rest of it will be review.
Okay,
Yeah.
sounds good.
So at least 2/3 of the time will be review.
Okay.
Oh, sorry.
It's like the grading one.
Not really. I kind of packed it away already.